Hi everyone and welcome to another very exciting tutorial. Today I've changed my background, my desktop wallpaper, to something looking a little more like space because we're heading into space today. And if you've watched some of the STC sessions, you might have come across one STC session where we created a nice little space game where we could shoot at aliens, move around our player with the digital crown of Apple Watch. So if you haven't seen it, definitely check out the conference bundle. It's in the video description below. But what we're going to create today is something focused on iPhone, and it's going to be pretty cool. So here it is. So we have sound effects, we have explosions, we have a moving star field. We're moving our player, the little shuttle, around with the gyroscope, so we're detecting motion, and we add some behavior to our spaceship here. So this is going to be pretty cool, and let's get started right away by firing up Xcode. And we're going to create a new game today. So let's select the game template right here. Let's call it Space Game Reloaded. And we're using Swift, of course. We're using SpriteKit, and we're targeting the iPhone. So let's click Next and create that on the desktop. And before we get started, let me give you a quick tour through the assets that we've got here. So first of all, we have a bunch of images, and these are our aliens, even if these are asteroids. This is our player, and we've got a torpedo right here. So let's open up the image assets folder, and let's move those images over, and of course you will find them in the tutorial files in the video description below or in GitHub. And what we will also do is adding our sound effects. So we have a torpedo here, which sounds like that. Photon torpedo, of course, and we have an explosion, which is that, and we're going to move them into our project, and let's make sure that copy items if needed and add to targets is selected. And we also have those two files which are particle emitters. So in order for that to work, let's first of all create a particle emitter. So I'm pressing Command N on the keyboard, and I'm scrolling down a little here, and what we want to do is selecting a SpriteKit particle file. And I click Next, and actually our explosion used the fire template, for example, so I'm just selecting fire right here. Let's click Next, and I'm simply calling that my particle and create that. And as you can see here, this gives us a nice fire particle emitter. And all we need to do is actually make some adjustments here. And so that we don't waste too much time here in that video, I have already provided those particle emitters for you. So just have a look around those settings. I think it's pretty easy to figure out what each of these settings do to your particles. So let me remove my particle here and put it to the trash. But what we want to keep is this Spark PNG file that was created with the particle. So let's move our explosion and star field to our project, and also make sure that destination, copy items if needed, is checked, and also add to targets. And with that, we're pretty much finished. So let's have a look at what this looks like. So this is our explosion, and this is our star field, which looks pretty nice. And we're now, let me make this a little bigger, we're now finished with creating adding all of the assets that we need for that project. And we can head over to our game scene first of all, and remove all of that unnecessary demo code or template code here. So the properties are removed. We're keeping the did move function, the did move to view function. So this is something like view did load, which we're going to use in a second. And also let's remove all of these other functions except for update. This is something we're going to need later. And with this now a lot cleaner file, we're starting by defining some of the properties that we are going to need. So let's definitely start with the star field property, which is an SK emitter node. And also, maybe let's add our player, which is an SK Sprite, no stream, SK Sprite node. And in did move to view, here we are going to add our player and also our star field to our game scene. And the only thing we need to do for the star field is taking it and initialize it with SK emitter node. And now we can choose a file named something like our two files here, explosion and star field. I'm choosing star field, which is simply this file. And by that, we can load that into our scene. We simply have to give it a position, so I'm putting it in the upper left corner, which should be something like 0 and for the X value, and 1472 now for the iPhone 6s Plus or 7 Plus or 6 Plus. And of course you should decide the correct position depending on the device that you're using, but since this is a tutorial, we are simply putting a hard-coded value there. And we're now using the star field. And the problem with the star field is that if you have a look at the particle emitter here, it takes some time to move down since we're starting at the top. And wouldn't it be cool if we could just advance the simulation a little and skip some seconds forward? And indeed, this is what we can do. We simply have to choose advanced simulation time, this function of or a method of SK emitter node. And let's just say we're skipping 10 seconds ahead. And with that, our star field should be all over the screen. And all we need to do is add a child, or self.addChild, which is our star field. And with that, we should already see it on our screen. So let's just make one further adjustment, take our star field and change the Z position to -1, -1. So that it is always behind everything else, like our player and so on. And let's now run this on a physical device, because these emitters don't look too cool on the simulator, but you can of course also test it on the simulator. And let me bring up Reflector here, and as you can see now, there is our star field right on a device. And now we should maybe add a player. And to do that, we will take our player property and initialize it with SK Sprite node, and we use the image named initializer here, and our image is called shuttle. So let's enter that here. And now all we need to do is adding a position. And we are not adding a physics body to our player, since it won't interact with any other objects in our game. It won't behave according to physics, to gravity, and nothing else, so we will simply make our lives easier by not adding a physics body. And now let's add a position for the player, which is a CG point. And we're positioning it at the center, so self.frame.size.width divided by 2. And so the anchor of our player is in its center. And then we're moving it a little to the top, so from the bottom. So let's choose the height, divide that by 2, and add 20 so that it's not too sticky at the bottom. And then we will simply add our child with the player, run this on our device, and have a look at it using Reflector. So here we go. And here is our little space shuttle, our spaceship, moving through space at high warp. And we're now adding some properties to our physics world and removing the gravity, for example. So we choose self, the physics world, and the gravity. And gravity is a vector, so we use CG vector here. And we don't want any gravity pulling us down, so and also no gravity pulling us to the side or anything, so we're setting it to 0, 0 in both directions. And what we also want to do is add a contact delegate to our physics world. So let's choose the contact delegate and set it to self, which means that we also need to adopt a specific protocol, which is named SK Physics contact delegate. So we're moving to the top, adding a comma here, and adopting SK Physics contact delegate, which means that we can later implement the did contact delegate method of this contact delegate. And with that done, let's now move to our score label, which we also need to define as a property here at the top. And also let's add a score integer, but first of all, the score label, which is an SK label node. And the score is an integer. We are initializing it with 0. And let's make that a computed property using did set to make some changes to our score label. So every time we update the score, we are also updating the score label, and change the text to score and the current score. So here we go. And with that done, we can now move down to our did move to view function again and initialize our score label with SK label node. We can give it an initial text here, which is score 0 at when we start our game. And then we can also give it a position, which is going to be in the top left corner. So CG point, X value is going to be, let's say 100, and the Y position is going to be self.frame.size.height minus 60, so 60 pixels away from the top. And we want to choose a different font. So I have selected American Typewriter Bold. Here you can, of course, choose whatever font you like. So American Typewriter -bold. And you can find a list of all fonts that are available on iOS on iosfonts.com. And you also see the names of those fonts, so make sure they're matching exactly what you're entering here. This is not only true for SpriteKit, but also for every UIKit app that you're creating. And with that said, let's change the font size, maybe to 36, and the score label and its font color to white, so UI color white. And let's change the score again to 0 to make an update according to our computed property. And then all that's left to do is add our child, which is the score label. So here we go. And now we run that on our device, wait until it's loaded, then bring up reflector. So here we go. And there is our score. And as you can see now, I must have made a typo. I've inserted a typo anywhere here. American Typewriter. So those font names exactly need to match. And here we go. As you can see now, we have American Typewriter Bold here. So let's move on and create some enemies for our game. So what we are going to do here is using a timer. So let me zoom out a little bit more again. So let's create a timer property for our game at the top. So this is going to be a game timer, which is a timer, and then we will move down again to did move, and the timer is going to be be fired every 3/4 of a second. So actually by changing that, you can increase the difficulty and creating more enemies. And we're going to use our timer and initialize it by using a timer and schedule a timer with a time interval, a target, a selector, a user info object, and with a repeats flag. And let's set this to 0.75 seconds. So every 3/4 of a second, we'll create a new enemy. The target is self, and the selector that we're going to use here is going to be a method that, or a function that we need to create, and we're going to call that maybe add alien. So add alien. Add alien. We add alien. Here we go. And the user info, we are setting this to nil since we don't need one. This would be a dictionary to pass along more information, and we set repeats to true. And with that done, we should now also create that add alien function. So let's remove those empty lines here and create a function here called add alien. We don't need any parameters here, simply a code block. And once we did that, our error moves away. And we're going to have a bunch of different kinds of aliens. So we are going to use an array for that. So let me create one as a property. And it's going to be called possible aliens. And these aliens are named after the images that we have already imported to our assets folder. And they're called alien, alien 2, and alien 3. And those aliens now need to be chosen randomly. And this is pretty cool. Since we have imported a gameplay kit, we can use some great functions that will make our lives a lot easier. So we're using the possible aliens array of strings, and now we use gameplay kit random source, then we use shared random, and then we choose array by shuffling objects. And now we can insert our possible aliens here and cast that to a string array. And with that, every time we add a new alien, our array is shuffled, and the all of our elements do have different positions in our array. So what we can do now is simply create an alien using SK_sprite node to initialize, and then we have an image named. And since we now have a shuffled possible aliens array, we can use our possible aliens array and simply using the first element, or 0 in that case. And by that, we always have a randomly chosen alien to display. And now what we can also do is bring it on the screen on a different position, or a random X position. So let's create a constant here, random alien position. And we again use the gameplay kit, random distribution this time, and we will have a lowest value and a highest value, and the lowest value is 0 for the X value 0, and the highest value, since we're on iPhone 7 Plus, is 414, and again this should be dynamic, but we're hard coding it right now. And then we will get a position, and we're simply using the random alien position and get the next integer. Since we need to use a CJ float for a CG point, we simply will cast that to a CG float right here. And then we can take our alien that we've already created, set its position to a CG point, and we need an X and a Y value, and we already have the X position. This is our random position. And for the Y position, we use self.frame.size.height of our screen and add the alien's size, alien.size.height, so that it's nicely put off the screen. And then our aliens actually need to respect the physics, or at least they need to respond to collisions, so we are going to need a physics body, and we're doing that by using our alien physics body and create an SK physics body, and we need to initialize that with a specific size, and we are simply using a rectangle of a specific size, which is the alien's size, which is only an approximation, but for our purposes this will do. And then we also set the physics body and its is dynamic property to true, and with that we're already done, almost done with our alien. What we now need is are three things actually: a category bit mask, a contact test bit mask, and a collision bit mask. And those are needed to calculate when we are actually hitting an alien with a torpedo. And to create those bit masks, we're heading up again and defining them as properties right here. So we're starting with, we can also actually create the bit mask for our torpedo here. So we are creating an alien category, and this is going to be an unsigned integer, and we're using 0x1 and shift the bit. And this is actually a bitwise left shift with a specific modifier to give each category a unique identifier to detect collisions. So for our torpedo, or our photon torpedo category, which is also U and 32, we're using another identifier, 0x1, and shifted in a different way. So now we have two different categories that we can use, and so now we are moving down again to our alien, and we are now first of all accessing the physics body, and I can copy that since we're going to do that 3 times, and choose a category bit mask, which is our alien category. I need to add a contact test bit mask, which is our photon torpedo category, and last thing we need is a collision bit mask, which we are setting to 0. And then we can add a child, which is our alien. And now we have an alien, but what we still need to do is moving it. And I'm simply adding here an animation duration, setting this to 6. And you could also randomly choose a duration here to make the game even harder. And we're applying now an SK action sequence to our alien, which will first of all move the alien from the top to the bottom of the screen or off the screen, and then we will remove that alien from our scene so that it doesn't consume too much memory. And to do that, we need an array, which is an action array, and this will hold a bunch of SK actions. So we're directly initialize that here. And then we use our action array and simply append some objects, which are SK actions. And the first one is going to be move to a specific CG point with a duration that we have already defined. So our CG point, let's make one really quickly, is going to be X is the position that we have already defined, our random position, and the negative alien size and its height for the Y value, which I need to add here. And the duration is our animation duration. And with that done, we can take our action array again and append a new action, which is SK action remove from parent. And now we have this cool action array. So we'll take our alien again, call the run function, and use SK action and sequence to pass along our action array. And now we still, the only thing that we still need to do is specifying that this is going to be a time interval. So we can also do that here by explicitly stating the type that we want to use here, and with that we don't have any errors left. And now we can build our game and run that on our device and have a look if we have some moving aliens. So here we go, and there we already are. So we have different kinds of aliens. We have our alien ships, we have those asteroids in orange and red at random positions moving from the top to the bottom. And as you can see, our number of nodes here is constant at 12, which means that we're also removing all of the aliens that are moving off the screen. So let's now think about firing a torpedo. Let's remove some of the lines here, make some more space. And we're now creating a function called fire torpedo. All right. And the first thing we want to do is actually hearing our cool sound when we fire a torpedo. And we do that by simply call run on self, and then we use the SK action play sound file named. And then we can choose our sound file, which is torpedo.mp3. And we do not want to wait for completion here. We simply want to fire away as often as we can and hear that sound. And then we will set up our torpedo node here, torpedo node. Initialize it with an SK sprite node with an image named, which is going to be torpedo. And then we will give it a position, torpedo node.position. And it's going to be the player's position, so player dot position, and then we'll move it up a little so that it is not exactly in the center. So let's use the position and its Y value and move it up by 5 pixels should do. And then we will again need a physics body for our torpedo, since it's going to interact with the alien ships and the asteroids. So I'm taking the torpedo node and its physics body property and initialize it with an SK physics body. And this time we can use a circle of radius. Since our torpedo is definitely a circle, we can give it a radius, and this is simply the torpedo node, and its size. And since we're using this, the radius, we're dividing it by 2. And then we will also set the torpedo's physics body, and its dynamic property to true. And then what we have to check is what's the problem here. So what have we got? Binary operator cannot be applied because we have to choose the width, of course. And with that done, we have our torpedo almost completely configured, but what's again missing is our contact category bit mask, contact test bit mask, and collision bit mask. So let's copy all of those 3 lines here, insert it here, and change the alien to torpedo node. And what we should do now here is give it different category bit masks and contact test bit masks. And this time, of course, the category bit mask is going to be the photon torpedo category, and the contact test bit mask is going to be the alien category. And this time for the torpedo, we're also going to use physics body and use precise collision detection. So there we even increase the precision of the detection, and now we'll add our torpedo to the scene. So self.addChild torpedo node. And then again, we will have to animate our torpedo so that it moves up. And as we did it with the aliens, we are also going to create an animation duration here, which is in time interval, which we've learned by now. And so I'm setting that to 0.3 seconds maybe. And you could also calculate a time interval based on your screen size and figure out different values depending on which screen size you're working with. But for now, let's keep it at 0.3 seconds. And we're again creating an action array as we did with the alien. And actually we could copy all of that here from our alien function and add it right here. And now all we need to do is change that a little. So we're replacing the torpedo node here, the alien node with the torpedo node. And then for the X and Y position, we have to choose something else, which is going to be for the X position of the torpedo, we use the player, its position, and its X value, since this is where the torpedo is going to originate from. And this is also going to be the X position where it will be when it leaves the screen. And so we're using a Y value of self.frame.size.height and maybe add 10. And the duration is the animation duration. We already specified that. After we moved it off the screen, we will remove it from parent, and then we will run our action. And with that done, all we need to do now is fire the torpedo once we touch our screen. So I'm simply implementing touches did end, or touches ended. And what we need to do here is fire a torpedo. And now let's see if everything works out as we imagined that. So let's head over, touch the screen, and we're firing. Isn't that cool? And now we have to hit our aliens and remove them from the screen. And then we're almost done. All we need to do then is add some motion detection so that we can move around our player. So let's directly move on to the so-called didBegin contact delegate function or delegate method that comes from the SK physics contact delegate. So let's maybe implement that right here. So didBegin contact, and we are going to need 2 bodies here. We have a first body and we have a second body, and we need to find out which body is the torpedo and which body is our alien, because the alien is supposed to explode. And we're going to do that by using 2 variables, a first body, which is an SK physics body, and a second body, which is also an SK physics body. And then we will check if contact body A and its category bit mask is less than contact body B and its category bit mask. And body 1 and body 2 depend on the category bit mask, or the shift that we applied of 0 or 1. And now if that is the case, we know that first body could be contact.body A, and the second body is contact body B. And if not, so else first body is going to be contact body B, so just reversed, and second body is going to be contact body A. And now we need to find out which body is actually the torpedo and which body is the alien. And to do that, we're going to compare bitwise which of the both category bit masks are identical. So we're using the first body and the category bit mask, and now using the ampersand operator here, and compare that to the photon torpedo category. So if this is not equal to 0, and if the second body and its category bit mask is alien category, also not equal to 0, then we can call a specific function and tell that a torpedo did collide with an alien. So let's write that function right here and call that torpedo did collide with alien. And we have a torpedo, which is going to be an SK_sprite node, and we have an alien, which is also going to be an SK_sprite node as parameters here. And then we can add our explosion, and so on and so on. So let's now call that function right here. So torpedo did collide with alien, and now we know that the first body and its node, and we convert that to an SK_sprite node, is the torpedo, and the second body and its node, also converted to an SK_sprite node, is the alien. And now we can play around with that and, for example, add an explosion. And we do that just as we did it with the star field. So we have an explosion, which is an SK emitter node with a file named explosion. And then we need to position the explosion, so we set the position. And we could also actually unwrap that here so that we can deal with it here. So position, and it's alien's position, because there the explosion should take place. And then we will simply call self add child and the explosion. All right. And then what we also want to do is play our sound of an explosion. So we run an action again, sk action play sound, sound file named, and this is going to be explosion.mp3, and we again do not wait for a completion here. And then what we want to do is take our torpedo, remove it, or maybe we should call that torpedo node here. So torpedo node, alien node, just that we don't get the images of Xcode. So here we go. So we take our torpedo node, remove it from parent, remove from parent. We take our alien, and no, the alien node, and we remove it from parent. And then there is still the explosion, but we actually do not want the explosion to, and I just see here that we should call that alien node. All right, sorry about that. And what we should consider is that the explosion cannot be removed yet because it needs to take place and it needs to explode, and we want to see that. So what we have to do is wait for a little time and then remove our explosion. And we can do that by calling self run, and then simply use an sk action, or we need to actually call a different kind of run function here, because we need a completion handler. And as you can see here, we have a run function that has two arguments, one with an SK action, one with completion handler. And here what our action is SK action and wait. And we will simply wait for about 2 seconds. And then we want to do what's inside the completion handler, which is explosion remove from parent. And all that's left to do is add some value to our score, maybe plus 5 points. And then we can run our game again on our device and see what happens as soon as we hit an enemy. So let's bring that up. And now we have to hope that an enemy is somewhere in, and here we go, in our shooting range. Let's wait for a few seconds here. No, that wasn't near enough. Maybe here, no. Here, yeah. And as you can see, we have our nice explosion, we have our nice boom sound, and now all that is left to do is adding a little more movement to our player by using the accelerometer. So let's move up again to our property list here and add some useful properties here. First of all, we need a motion manager, which is a CM motion manager. And as you can see, we don't get code completion here because we need to import core motion in order for this to work. And what we also need is a variable here, which is the X acceleration that we get. So let's use X acceleration here, which is going to be a CG float, and initialize it with 0. And then in our did move function at the very bottom, we add some more initialization for our motion manager. So we supply it with an accelerometer update interval, which is going to be 0.2. And now we take our motion manager and tell it to start accelerometer updates with an operation queue and a handler. And we're simply using the current operation queue. So let's hit enter here, and the current operation queue, we need to unwrap that. And we're going to get a handler here with accelerometer data and an error. So here we go. And then we can check if there is accelerometer data. So if let accelerometer data is equal to data, and if we have data, then we should also use it. So we use acceleration and use the accelerometer data and its acceleration. And here we go. And we're now going to update our X acceleration property to use it later to move our ship around. And you have to play around with these values a little. I simply took the acceleration and its X value, and actually just 3/4 of it, and added the current X acceleration, or let's say 1/4 of it, to get a nice result. And then we need to cast that to a CG float, since this isn't one. And then this should actually work. So let's build that. And now let's see. Is he happy? Yeah, build succeeded. And with that, we now have acceleration data, which we can use in another delegate function, which is called did simulate physics. So let's move down here and insert that here in did simulate physics. And what we can do is simply now take our player and its position, its X position, and add the acceleration data. And again, this is something you need to play around with a little, so I multiplied it by 50. And then to move the player, if the player reaches the left of the screen to the right side of the screen, we need a little if statement. So we check if the player and its position and its X value is less than -20. We set the player's position to the right, so it's going to be a CG point So self.size.width plus 20, and the player's current y position, position.y, and else if our player and its position and its x value is greater than self.size.width plus 20, then we want to move it to the left side. So again, player.position equals CG point with x and y, and we have minus 20 here, and position player dot position dot y. And with that, we should be done with our game. So let me run that. On our device, we of course do not have a game over screen or multiple different difficulties or something like that, but I think it's pretty cool nonetheless. So let me move the device around, and as you can see, I can move it to the left and to the right by tilting it. And now I'm going to shoot, and here we go, and this works, and I'm getting pretty high scores here. It's pretty nice. So I probably should stop now. Okay, this one. Oh, come on. Cool. So with that done, we can now move back to the code for a second, and I'd love to see some of you maybe making this game a little harder, displaying a game over screen once one of the aliens reach the bottom of the screen, or changing the difficulty a little, or maybe even adding different levels. But I hope you had fun implementing this. I definitely had fun playing it, and thanks for watching, and I'll see you next week.